maybe I made tonight's TV theme song a little too easy tonight. There will be a new season starting before too long, and I, like many Americans, are looking forward to the new season. So, but anyway, welcome to another episode of the Flip Classroom. Our title tonight is Rules of Exponents, and they're often referred to as the Big Four. And all of these rules you're quite familiar with individually. I think as freshmen in Algebra 1, you looked at each of these rules individually. We're going to refresh your memory of the basic rules, practice a couple of easy examples. And then the big difference this year in Algebra 2 is that you're going to see these four rules combined together all in one problem. It is very possible that you might use all four of these rules to simplify one expression this year. Probably the biggest one that we're going to spend the most time on is the negative exponent rule. I think that's the one that we're going to probably use the most by the time we're all said and done. Our first rule is called the product rule of exponents, and simply all it is saying is that x raised to the a times x raised to the b is equivalent to x raised to the a plus b power. What we like to say is for multiplying like bases, and I'm referring to this x here times that x there, then all we're going to do is simply add those exponents. A good example, we could say x squared times x to the third is equivalent to x to the, yes, you've guessed it, fifth power. Just as an illustration, x squared is equivalent, is really x times x, and x cubed is x times x times x, and I think you'll quickly realize that that is also x to the fifth. But we don't really need to write all of these out. We're going to simply add these exponents together in our head and get the fifth power. Our second rule for exponents is called the quotient rule, and it simply says that x raised to the a divided by x raised to the b power is equivalent to x raised to the a minus b. Again, nothing earth-shatteringly new for you, but simply if we're going to divide like bases, referring to the x divided by the x, then we're simply going to subtract the exponents. Another good example here, if we said x to the fifth divided by x squared, we would simply subtract those exponents and get a quotient of x to the third. Again, x times x times x times x divided by x times x. We could kill two of the x's on top with two on the bottom, and all we're left with is x to the third. Our third rule is called the power rule, and it simply says that if we take the quantity x to the a and we try to raise that entire quantity to the b power, we're going to simply multiply these exponents and say x raised to the a times b power. Again, we have power raised to a power, that's the a raised to the b, and we just multiplied the exponents together. Another good example is if I took x squared and raised it to the third power. Here's a good example of a power raised to a power. Simply say x to the sixth. Kind of the long way there is we could say x squared times another x squared, and actually now I'd be using the first rule we went over a few seconds ago called the product rule, where now we're multiplying like bases. We'd add all those exponents up and again get x to the sixth. So either way you want to approach it, you're going to end up with x to the sixth. I think it's easier to just stay here and multiply the two exponents together. Our fourth rule is called the negative exponent rule, and this is, like we hinted earlier, that we're going to spend most of our time with this one here. And it simply says that if the base moves from the numerator to the denominator, or vice versa, then simply the exponent's going to change signs. There's three examples I want to use to illustrate this one. Number one, if I take x and I raise it to the, we'll say, negative m power, we could rewrite that as 1 over x to the positive m power. You'll notice, I think our rule describes that quite fairly. It says the base is moving from the numerator to the denominator. Right, and when we began that problem, x was in the numerator. That's over 1. And then we simply moved that x from the numerator down into the denominator here, and now the exponent is positive. The second illustration I want to use is, what if I started with 1 over x to the negative m? You'll notice right now x is in the denominator. If I simply move him to the numerator, now the exponent changes signs and becomes positive. That is, of course, over 1. We don't have to say over 1, but it is maybe convenient to illustrate here. Our third example that I want to throw at you is, what if I took the quantity x divided by y and I raised that entire quantity to the negative m? First of all, my numerator is going to move to the denominator. What used to be in my denominator is now in my numerator. And once those bases change, we now are raised to the positive m power. So those are three good examples to illustrate that when our base moves from the numerator to the denominator, or vice versa, then the exponent is simply going to change. We're now ready to jump in and try a bunch of examples. I've got a grand total of 8 for you here tonight, and we're going to warm up nice and slow. The first one I want to do is I want to take the quantity m to the 6th and raise that entire thing to the 2, maybe that's going to show, it's not showing up, 2/3 power. It doesn't look like it, but that exponent's supposed to be a 2/3. What we're going to do here, first of all, ask yourself which of the 4 big rules that we just went over applies to this problem. Hopefully you said the third rule, the rule that said we have a power raised to a power. In that case, we're going to simply multiply those exponents together. Yeah, feel free to use your calculator here if you want to, but 6 times 2/3 is going to give us 12/3, which turns out to be a 4. And that's my final answer. Our second quick example here, and hopefully this one will be more legible. Let's take the quantity w to the -5 divided by w to the -7. And we're going to raise that entire quantity to the 1/2 power. Certainly looks a little more intimidating than the last one. What I'm going to do is I'm going to first start by focusing on just what's inside the parentheses. I'm ignoring the 1/2 power on the outside. And ask yourself which of the 4 big rules applies to what we have on the inside of these parentheses. And hopefully you said rule number 2, the quotient rule. The quotient rule says that if you're dividing like bases, we are simply going to subtract those exponents. And we could certainly go off to the side here and say, okay, -5 minus a -7 turns into -5 plus 7. So I have a new exponent of 2. And then, of course, we still have that outside exponent of 1/2. Now, we've got one more step to do. We're now going to go use rule number 3, called the power rule. We have a power raised to a power. If I multiply those powers together, I end up with a 1. We don't have to write the 1, so my final answer would simply be W. Okay, our third example wants us to take the quantity 3c and raise it to the -2 power. Rule number 4 that described our negative exponent rule simply says we're going to move our base. Now in this situation I would say our base is the entire quantity 3c. Not just the 3, not just the c, but the entire quantity 3c. We're going to move them from the numerator to the denominator. And when we move that quantity to the denominator, our exponent changes signs. It's now a +2. And the last thing I'm going to do is I'm going to go ahead and raise both of the factors inside those parentheses to the 2nd power. 3 raised to the 2nd is 9. C raised to the 2nd will simply say c squared. And that, ladies and gentlemen, is my final answer for number 3. Alright, moving on. Our fourth example wants us to take the entire quantity, 3 times x times y to the -1 power, and raise that entire quantity to the -2 power. Hopefully you can read the -2. I've got to learn from my mistakes and not try to get my pen as close to the top of the screen here. But my first move here is to take that base, which in this case is the 3x times y to the -1. I'm going to move that base from what used to be in the numerator down into the denominator, and now that outside exponent is now positive. The key that I really want to point out here, is that the only exponent that changed signs was the one that was on the outside of the parentheses. Notice that everything inside the parentheses, none of that changed signs. Now we can go ahead, we could raise everything inside those parentheses to the 2nd power. My 3 turns into a 9, my x turns into an x squared, and my y, if I multiply those exponents together, gives me a -2. That's, of course, our power rule. Now, you might be tempted to stop there, but it is good math etiquette to not leave negative exponents in our answer. So what I'm going to do is I'm going to move the y squared term up to the numerator while leaving the 9 and the x squared in the denominator. Why only move the y term? Well, it is this rascal right here. That's the only factor that had a negative exponent. Therefore, that's the only factor that I moved. I moved him up to the numerator while leaving the 9 and the x squared where they were in the denominator. Ladies and gentlemen, this here is our final answer. Our fifth example wants us to multiply two quantities together. Let me ask you a question here. This first quantity in this first set of parentheses here, 3a to the fourth negative, and then b to the 5/3, is that a monomial or a binomial? This quantity right here is, although it may look big and ugly, it is just still a monomial. And then over here, this quantity here is still a monomial. The reason I emphasize that is because later on in this chapter, we're going to turn these into binomials, and it's going to totally change how we approach this problem. So as it is, since they're monomials, we can just simply start multiplying like terms here. My coefficients are 3 here and a 1 over here. If I multiply them together, I've got a 3. Next, I'm going to multiply my a to the negative 4th times my a to the negative 2. I'm going to be using my product rule, the very first rule we went over, which means I'm going to add my exponents. Off to the side, if I take my negative 4 and add my negative 2, that's going to give me a new exponent of negative 6. Then I'm going to focus on my b's. Again, I'm multiplying like bases. I'm going to use my product rule. And if I take my 5/3 and I add it to my 1/3, that gives me 6/3. Which is really a 2. So I'm going to say b squared, squared being my new exponent. Whoops, time out. Is that my final answer? Not quite. Let's pretend I didn't write that part right there. Good math etiquette. We're going to rewrite this so that all exponents are positive. Notice I left the 3 and the b squared in the numerator. The only term or factor that I moved to the denominator was the a to the 6 because this is the only factor that had a negative exponent. All the others were good to go already. Now we could say that this is our final answer. In example 6, they're asking me to take one monomial and another monomial. And again, I want to point out that both the numerator and the denominator right now are monomials. Once they become binomials later on, that's going to totally change how we approach this problem. I'm going to focus on dividing the like terms or the like factors. My coefficient on top is a 1. 1 divided by 3 is, of course, 1/3 here. Then if I line up my x's, in this case, I'm not using the product rule anymore like I did in example 5. I'm now using the quotient rule that says if I'm dividing like bases, I'm going to simply subtract those exponents. If I take the negative 1 and I subtract the negative 5, I'm getting an answer of 4. Therefore, 4 is my new exponent on the x. And then finally, we're going to move on to the y's. Again, quotient rule says I'm going to take the exponents and I'm going to subtract them. 4 minus a negative 1 gives me a 5, and that 5 is the new exponent on my y. As we quickly scan the problem, we don't have any negative exponents, which is a good thing. However, I am going to rewrite this one more time. I'm going to say x to the 4th times y to the 5th, and that entire thing is divided by 3. That's just a little cleaner way of expressing our answer. And we've got 6 examples done. We've got 3 more in store for you. They're going to get a little harder, but example 7 being very similar to example 6. They're asking me to divide one monomial by another one. We're going to start by focusing on the coefficients and just reduce them. 2 divided by 4, I'm going to say is equivalent to 1/2. If we focus on the x's, again, quotient rule says we're going to subtract our exponents. Take your negative 8, subtract your 2, and that gives us negative 10. Therefore, negative 10 is my new exponent on the x. And then last but not least, we'll focus on the y's. Take your exponents, subtract them, I should say. 2 minus 5 gives me a new exponent of negative 3. Negative 3 going right there. Now this one's very feisty to clean up. You'll notice we want to move a lot of the terms around. When I express my final answer, my numerator is simply going to be a 1. I can express the 2 in the denominator, just like in the last problem we put the 3 in the denominator. We'd also want to move our x to the denominator. Then the exponent changes signs. It's a positive 10. And we'll also move our y to the denominator, and our new exponent is now a positive 3. And that is our final answer to number 7. Okay, as we get ready to tackle number 8 here, I hope you can read this bottom exponent. But anyway, let me read the entire problem to you just to make sure. The numerator is 3 times x to the negative 4th times y to the 5th. And then on the bottom, we have the entire quantity, 2x cubed y to the negative 7th, raised. This entire quantity on the bottom is being raised to the negative 2 power. So there's a couple different ways we could approach this, but here's the way that I like to go about it. The first thing we're going to do is we're going to move the entire quantity that's in the denominator up to the numerator. What do you think that's going to do for us? Why does that help us? If we move that entire quantity up to the numerator, this outside exponent that used to be a negative 2 is now a positive 2. Again, let me emphasize, when I moved that quantity up, only the negative 2 became positive. None of the exponents on the inside of this quantity changed when I moved him up. Next thing I want to do is I'm going to, again, focus on that second grouping. We're going to now square every factor that's inside this quantity right here. The 2 turns into a 4, the x cubed. Just ask yourself, what rule are we using? Are we going to use the product rule or the power rule? Hopefully you said to yourself, the power rule, because we have a power of 3 raised to a power of 2, which now gives us a power of 6. And then the y, again, if I multiply those exponents, gives me a negative 14. At this point, you've survived the worst part of the storm, and now we're going to just multiply these two binomials together, focusing on the like factors. The 3 times the 4 gives you a 12. X to the negative 4th times x to the 6th. Now we're using our product rule. We'll add the exponents and get a 2. And then on the y's, we'll add the exponents again and get a negative 9. My very last move over here is to leave the 12 and the x squared in the numerator, and to move the y down to the denominator so that the exponent could change signs. Here is our final answer. Our last example, you'll notice we do have a monomial divided by another monomial, but this time we're, instead of just raising one of those quantities to the negative 2 power, we're raising the entire fraction to the negative 2 power. I want to draw your attention to earlier in the notes when we said you might have x divided by y raised to the negative m. And if you recall, we said that's really y divided by x now raised to the positive m. We're going to use that rule on this particular example here, and we're going to move. I'll tell you, it's really been a challenge to write all these exponents in a neat, legible fashion here with this particular pen they want us to use. Anyway, we're moving the x cubed and the y to the negative 4th on the bottom. Notice none of those signs on these exponents changed. All that did is now the exponent on the outside, which used to be a negative 2 on the outside, is now a positive 2. Nothing on the inside changed. Signs of really, that's really important to take notice of. Now we can go ahead and we can square everything that is on the inside. What used to be a 3 is now a 9. We're going to use our power rule all the way through here. We're going to multiply all these exponents by 2. So now we have x to the negative 4th, y to the positive 12th. Feel free to hit the pause button and try to write out your denominator, and then come back and hit play and see if you get the same thing I did. Okay, if I multiply the exponents on the bottom, I now have x to the 6th and y to the negative 8. Well, now we're going to use our quotient rule, which says we're going to subtract all of our like exponents, focusing on the coefficients. 9 divided by 1 is 9. Let's see, negative 4 minus 6 is going to give me a new exponent of negative 10. And on the y's, if we do 12 minus a negative 8, that's really 12 plus 8, which gives us a 20. Ladies and gentlemen, we're one step away from finishing up these notes. We're going to leave the 9 in the numerator. We're going to leave the y to the 20th power in the numerator. And then we're going to put our x to the 10th power in the denominator. Of course, by moving him from the numerator to the denominator, that 10 is now positive. Here is our final answer. Well, ladies and gentlemen, I hope you could read all the exponents. I know that some of them were challenging. Hopefully we can take these examples and use them in class tomorrow and be very successful. Good luck tomorrow, and we'll see you soon. But I think we can handle them. Signs.